Hi, today's video will be on quadratics in vertex form. Your objective for this lesson is to be able to look at a quadratic equation in standard form and write it in vertex form, thereby being able to identify the vertex and the axis of symmetry. Also, you will be given the equation in vertex form and be asked to identify the vertex and axis of symmetry. So recall that we have been working with quadratic functions in the form f of x equals ax squared plus bx plus c. And remember that when talking about the vertex, we are referring to the maximum or minimum point when the parabola is graphed. To find this vertex, we are going to make sure that we identify the a and b value from the quadratic function in standard form. So for this slide here, you might want to reference given f of x equals ax squared plus bx plus c. When we are referring to b and a, we are referring to a as the coefficient of your quadratic term and b as the coefficient of your linear term. So for example, if given f of x equals x squared minus 4x minus 12, our a value is 1 and our b value is negative 4. So to find the vertex of this quadratic function, what we'd want to do is plug it into what's given here. So this says that to find the coordinates here, remember the max or the minimum point, we want to first, and I'm going to put a v out here to represent the vertex point. The opposite of b, where b is negative 4, is going to end up being a positive 4. So the opposite of negative 4 divided by 2 times our a value, which is 1. So that means if we simplify this, we have positive 4 over 2, which is going to be a positive 2. So what we have found thus far is the x-coordinate or initial coordinate for our vertex, simply by plugging in the opposite of b, so positive 4, over 2 times a, 2 times 1 being 2. So now that we have 2, let's talk about how we find the y-coordinate for our vertex. To find the y-coordinate of our vertex, we want to first store our x value as 2 in our calculator. So essentially what we're saying is if we input a 2, so let me talk about this first. What I'm saying is if I input a 2 right here and make this f of 2, then this would be equal to 2 squared minus 4 times 2 minus 12. So I would want to substitute a 2 everywhere I see x. And there's a couple of different ways we can do that in our calculator. If we go ahead and take 2 and store that value as x and hit enter, we can then type in x squared minus 4x minus 12 in our calculator, right on our home screen. And that value will be negative 16. That means my vertex is 2, negative 16, because f of 2 had a value of negative 16 when we evaluated, okay? So we need to really learn that formula, negative b over 2a, to get our initial coordinate. Then we substitute it back in. So basically at that point, just so you understand this notation, this says f of negative b over 2a, or opposite of b over 2a. So what we were finding were, this ended up being 2, and this would be f of 2. So you'll understand that notation, 2 and f of 2, where f of 2 was negative 16. So now let's take a look at our next slide. And this refers to the general equation of a quadratic function in vertex form. So this is something we have to memorize, so make sure you memorize this. And the way we read it is y equals a times the quantity x minus h squared plus k. So the quantity is squared. So again, y equals a times the quantity x minus h squared plus k, where our vertex is easily identifiable in this form by looking at our h and our k values. Okay? Recall that if this was our parabola, and we have our vertex here, hk, our axis of symmetry is that vertical line that passes through, that kind of makes our parabola symmetric about that line. And because of that, if this was our point hk, our axis of symmetry would be x equals the h value here. Okay, we've talked about that yesterday. So now let's look at example 1. If we're looking at y equals, and it's easier to see it on the PowerPoint, but y equals negative 3 times the quantity x minus 5 squared plus 4, we can easily identify the vertex by looking at this h value and this k value. One thing I want you to keep in mind is that if this is x minus h or x minus 5, let's put this over here, y equals a times x minus h quantity squared plus k. If it is in this form, then we can see how this matches up. So our a value is clearly a negative 3, our h value is clearly a 5, and our k value is clearly a positive 4. Okay? So our vertex would be 5, 4. So some of you may look at that and go, well, how come? I thought that h was a negative 5. In actuality, this formula is contains x minus h. So that's x minus 5. So the h is actually a 5. So because of that, and because 4 ends up being a positive 4, just like it reads, I usually tell students to remember switch keep. As in, if this appears to be a negative 5, it's really a positive 5, so switch your thinking here, and that would be a positive 5. While this being a plus 4, you keep it a positive 4. So our vertex is our vertex is the point 5, 4, while our axis of symmetry is x equals your h value, or x equals 5. So looking at this next example here, example 2, y is equal to 2 times the quantity x plus 3 squared minus 5. Okay? The first thing you have to be able to do is to identify the vertex. Our vertex, again, think switch, keep. If this is x plus 3, our h coordinate here is negative 3. Why? Because what this had to equal is 2 times x minus a negative 3. Oops, I guess I don't need that. Well, yeah, I did, but with the squared on the outside. Sorry. All right, and the x minus a negative 3 means x plus 3. So see how that works? To turn this to a plus 3, h had to have been a negative 3. While this is still a minus 5 out here, we're going to keep that negative 5 and identify our vertex as negative 3, 5. Our axis of symmetry, the other thing you have to be able to identify, again, is x equals h. Since h is negative 3, our equation will be x equals negative 3. Okay? Now let's talk about writing the quadratic function in vertex form. The first thing we always want to make sure our equation is in standard form, which means if we had something like 5x squared plus y equals 3x minus 4, we would want to make sure it is in the form y equals ax squared plus bx plus c, which if you compare the one here above, our quadratic term needs to be relocated. So if I relocate it, I would have y equals a negative 5x squared plus 3x minus 4. So that's what we mean in step 1 by making sure we write the equation in standard form, is that it is y equals, with our quadratic term, then our linear term, then our constant term. Next, we need to identify the vertex, same as we did earlier, using our opposite of b over 2a, and then evaluating f of that h value. So let's get started. We first have to identify our a as -5 and our b as 3, right from our given equation here. To do that, once we have that, and granted I made this equation up, it's not on your PowerPoint. So now that we have these values, we would then say, well, let's find our coordinate for our vertex. So the opposite of b would be -3 over 2 times a, or 2 times -5, and that would give us -3 over -10, or +3/10. So don't get nervous if we end up with a fraction here. Next, we want to simply evaluate that value. So this would be evaluating f of 3/10. Okay? So we're just about done. Now we simply want to store 3/10 as our x value. So again, I'm going to use my calculator. 3/10 store as x. Okay? And then evaluate that function if x was 3/10. So I want to now, on my home screen, type in -5x squared plus 3x minus 4. Hitting math, enter, enter. And we get -71 over 20. So not the prettiest of numbers, but we are evaluating it correctly. And that would be our vertex. So remember, in vertex form is y equals a times the quantity x minus h squared plus k. Now we need to recognize that our a value was a -5, and then plug in our h and k. So x minus a +3/10 squared here. And since it would be plus a negative, I'm going to change this to minus 71 over 20. Okay? Now what we should make sure is that what we started with and what we ended up with in vertex form are equivalent equations. So let's check it out. Remember, we've done this many times. So on my home screen, or on my calculator, I'm going to type in -5x squared plus 3x minus 4. Hit enter. And then type in my equation in vertex form. And see how I get equivalent values here? So that tells me my standard form is equivalent to my vertex form, because I got the same values here. And remember, it doesn't matter what value is stored for x, we should end up with equivalent values here if we're just testing equivalence. I'll do one more, and then I'll ask you to work on the next ones. So on this next slide, and I'm not in play mode, so you're going to see the answer down here at the bottom. We're going to see how can I work from my given equation down to vertex form and be able to state the vertex. Well, again, when looking at our equation, we want to find the opposite of b over 2a. So remember, vertex is what we're looking for. The opposite of b would be +8 over 2a, so 2 times 1 is 2. Hopefully that makes sense. Okay, opposite of b, so the opposite of -8 is 8, over 2a, 2 times 1 is 2. 8 divided by 2 is 4. Next, I again want to take my calculator and store my value of 4. So 4, store as x, enter. Then evaluate my expression right here on my home screen by letting it substitute 4. And I get a value of -6. Since I have my vertex, remember a is equal to 1. So I want to plug in right here into y equals a times the quantity, x minus h squared plus k, substituting 1 for a, because my a in my initial quadratic equation is 1, x minus 4, that's my h value, squared, plus a negative 6. Well, if I do plus a negative 6, if I substitute that, positive times a negative gives me a minus, so that's where I end up with this. So when I get done, I want to have y equals x minus 4 quantities squared minus 6. Identifying my vertex, remember switch, keep, so that should hold true. My vertex would be positive 4, negative 6, just like we found earlier. And of course, the last thing I would need you to be able to do is identify your axis of symmetry, which would be x equals your h value, 4. Okay? One thing I want you to keep in mind, again, we should be able to verify these on our home screen. Make sure x squared minus 8x plus 10 is equivalent to the quantity x minus h squared minus 6. But we can also verify it graphically. So last thing I want to share is to make sure that we type this in. X squared minus 8x plus 10. Again, just as a reminder, we can verify that these are equivalent also by typing both options, standard form and vertex form, into y equals in our calculator, going to second graph and verifying that all of our ordered pairs for x and y1, which is standard form, and x and y2, which is vertex form, these values should always match up if our equations are equivalent. I can also verify if 4, negative 6 is indeed my vertex. So let's graph it. When we look at the graph of this equation, we recognize that it does appear that 4, negative 6 is our vertex. 4, negative 6 in quadrant 4 here. Positive x and a negative y. One thing I want to remind you of how to do, you did this in Math 1, is to find the vertex on your calculator. If we go to second trace, see above trace it says calculate, and we want to calculate our minimum value. We know it's a minimum because it looks like a valley. Second trace 3. We can move our right arrow near our vertex, hit enter to mark it. See how it asked for left bound, and now we have to move it to the right of the vertex instead of right bound. We want to be near but not directly on our vertex. If we hit enter, it then asks us to guess, or asks the calculator to guess. We hit enter, and we do see that it is 4, negative 6. Do not fret if you get 3.99 repeating. That just means it would round to 4, and our calculator is using precision based on where we set our left and right bound. So you very well could do this and end up with exactly 4, negative 6. But that verifies it right there, that our equations are correct and that our vertex is 4, negative 6. All right. Since we already have the video at 18 minutes, I'm going to go ahead and stop, and we will finish going over this tomorrow.